All right, guys, here we are at our 3.8 video notes. Today, we're going to be talking about transformations of our linear functions. And what we're going to go ahead and do first is type in this website, desmos.com. And when you go there, you'll actually click on Graphing Calculator. Okay. So you'll click on Graphing Calculator. And this is an awesome program. It's mainly used for quick graphing, but it also highlights a lot of great points that we're going to talk about today. So the first line that we're going to go ahead and graph is pretty much just our standard parent function, y equals x. Okay. And so we know, based upon our previous lessons, that we end up with a straight line that goes something like this. It is diagonal. And the reason why we're seeing this is we do have a y-intercept. Keep in mind, this is still y equals mx plus b. All right. Our y-intercept, that b value, just happens to be 0, though. Notice how right here, it is crossing this y-axis at 0. And so that's why, really, if I take my y equals x and I add nothing to it, notice how it stays exactly the same there. And so we do have a b value. It is 0. Now, in terms of our slope, well, when we look at our slope, it looks like from this point to this point, 0, 0 to 1, 1, we notice that we're rising 1 and then running 1. So as a result, our m in this situation is 1. Notice how that didn't change anything at all. We still end up with that same line. Now what we're going to go ahead and do, so there, as you guys can see, y equals mx plus b, right? Y equals mx plus b. Now what we're going to go ahead and do, though, is change some of these values from our m and our b, okay, and see really the impacts on what's happening to our graph. So the next one tells us to enter in y equals x plus 3. And so what we notice here with the blue line is it looks like it just shifted our graph up 3 units, okay? And notice, again, it's still rising and running at that same rate, though. We see these parallel lines going on, okay? So when we added that b value, like going up 3, from 0 to 3, it looks like it vertically changed our graph up 3 units there. Now let's go ahead and graph the next one. We have y equals x minus 5. And take a guess what's probably going to happen to our graph here when we do that. When we enter that, we do notice that, yep, our graph looks like it vertically shifted down 5 units from that parent function. We still have that same slope, though. It's still rising and running at that same rate because our slope here is still 1. And again, still 1. So mainly right now, we're mainly just emphasizing what's going on with this b value. What happens when we, in fact, like add a value instead or subtract a value instead? So that y-intercept, what's going on there? Well, we're mainly just seeing those vertical shifts happen, okay? Now we're going to go ahead and enter in this kind of slider one where we have y equals x plus b. So you literally just enter x plus the letter b on your keyboard. And then it asks for this slider. You're going to go ahead and select that. And this is a really neat feature that Desmos offers. What you can do is we currently, our b value is set at 1. You can actually shift this around. And we're looking at the purple graph here. And when I shift this, notice how it looks like it is changing all the time right there. So our b value is shifting up and down. But our slope every single time is still 1, right? So we're still getting all these parallel lines. Now, if it were at -1, notice our b value is at -1. But if I shift up my b value, so maybe I bring it up, it looks like my line is still the same line, but my y-intercept is changing, okay? So imagine your graph is just going up or down depending on that b value. And that makes a lot of sense because our y-intercept controls really our initial value, that start point. All right. So next, what we're going to go ahead and do is we're going to do our y equals 2x. So y equals 2x. And then right underneath that, we're going to enter in our function y equals 5x. Let's see what happens when our slope changes. So this is our original function, y equals 2x. Now when I bring in y equals 5x, notice how it gets steeper on that scenario. And the reason why it gets steeper in that scenario is because our rise over our run has become greater. See, in this first one, it was 2/1. Whereas in the bottom one, it's 5/1. You're rising up 5 and running 1. So that's why we're seeing that level of steepness occur there. All right. Again, there's 2/1, and then there's that 5/1 where it gets more straight up. Okay. Now, if, for example, this is not on the notes packet, but just to kind of help illustrate, if we had, like, let's say y equals 1/2. So maybe our slope was a fraction, 1/2 x. Notice how here in this scenario, it looks like it flattened out more. And that's because our rise is going a little bit lower now. So we're only going up 1, but then we're running 2. And then another one might be like, hey, maybe we're going to go y equals 1, just to really exaggerate it, 1/8 x. Notice how it flattened out even more. That's because we're only rising 1, but then we're running over 8. So it becomes a lot more flat and leveled. So the steeper our slope, what we're noticing, the steeper our slope, the bigger your number here for m, the more steep it gets. Whereas if you have a fraction and it becomes more closer to 0, it's going to become more flat and level there. Okay. And just like with the others, we have this awesome feature where we can go ahead and add a slider. Here, we'll go ahead and get rid of a couple of these. So we have y equals mx, and we're going to add this slider. Now currently it's defaulted to 1. Okay, so this is our purple line right here. And as we said, if we increase our slope, in other words, if m gets to be a bigger number, we should see that it gets steeper. And look at that. It looks like it does. Now it's at 2. And then as we get larger and larger and larger, it becomes that value 5 that we saw. So it's getting steeper. And then it can get even really much more steeper than that. Okay. Now, again, we kind of saw these quick sketches of the graphs too, where, well, what happens if it's a fraction? Well, we notice that it becomes just more level, to the point where even if it's then just 0, we see that flat horizontal slope. Okay, so this is what it looks like when it's a fraction. All right, now we're going to go ahead and clear these guys. And what we're going to do in this point is we're going to have our normal parent function y equals x. Okay, that's the normal parent function, that you normally graph. B value is 0, rise 1, run 1, rise 1, run 1. Slope is 1 there. Now, what happens when we add this negative value in front? So currently we're looking at E. We're on part E now. If we add a negative in front, so negative x, there's our blue line. Notice how it just basically flipped our graph about this x-axis. So once was going up is now going downward. And the reason why is because this negative is making those values become negative. So what was once 1 going up to 1, at the x value 1 times a -1 is going to make it -1. What was once a value of 2 for the red, if we plug 2 in there for x, 2 times 1, normal one, would have given us 2. But on the blue one, if we plug 2 in, 2 times -1 would give us -2. And so that's really why we're seeing this flip about the x-axis. Okay. Again, 3, if you plug that into the red function, and you take 3 and multiply it by normal 1, you get normal 3. If you take 3 and you multiply it by -1, you get that -3 going on. Now, what about these negative x values? Well, again, for the red function, we'll just take -2, for example. For the red function, if we took -2, x to be -2, and we plugged it in here, well, -2 times a +1, that would give us -2. And so that value would have been there for our normal parent function. Whereas for the blue guy, if we took -2 still, and we plug in -2 in for x, -2 times -1, that negative in front, so -2 times -1, that would give us actually a +2. And that's why we see that point right there for the blue line. So next up, what is essentially going on here? You're taking your graph, and anytime you have a negative in front of that x value like this for the parent function, you are flipping your graph about the x-axis. Okay, that's what we call a transformation, a linear transformation. Now, in terms of like what is the slope? Well, as we could tell from the red line, your normal parent function, that was our +1. And then for the blue line, that is a slope of -1. Okay. But again, how are the graphs y equals x and y equals -x geometrically related? They are flipped about the x-axis. Okay. So for example, I'm going to make up 2 different ones just so you can kind of reference to. So let's say, for example, we have y equals, we'll even include some fractions in here, 2/3 x. So we see this green line, right? You know, it's kind of just going up. It's a little bit more flat and level than our normal parent function, but it's still going up, right? Then all of a sudden we say, hey, we're going to enter in y equals -2/3. So same number, just it's negative x. Notice how everything that was going up is now flipped about this x-axis. Okay. But you do see a lot of symmetry going on with this. Okay, just by throwing that negative in there. All right. So now let's go ahead and create some definitions. All right, now that we've seen all of those different graphs kind of in action, let's go ahead and create these definitions. So again, we've already done our A through E parts. For our definitions, when the y-intercept, remember our first graphs we saw was dealing with the y-intercept, the b values. When the y-intercepts, or when the y-intercept is changed in the function y equals mx plus b, then the graph we saw vertically shifts. Okay. And so when b increased, in other words, when b was like 2, for example, or if b was 7, let's say, what we saw there was that it translated up. So it vertically translated up. Yeah, you could do vertically. Vertically translate or vertically shift, they mean the same thing. Okay, but if b decreased, so that was when we saw b to be -5, that is where our vertical shift down, or you could use translate too. They mean the same. All right. So that b value pretty much controlled our graph going up or down, depending on the value for b. Now, when the slope m is changed in the function y equals mx plus b, then it changes the steepness of the line. So that's what's going to go inside this next one. It changes our steepness of the line. So if m increased, this is that scenario where we saw like m to be from 2 to like M to becoming 5. So see how it went up there? In that scenario, we saw that the line got steeper. So the graph got steeper. Okay. Another term that a lot of math teachers use is the line stretched. So if you hear that in the future, you will hear that in the future. But in terms of lines, it's got steeper. Now, if the absolute value of M decreases, this is where our fractions occur. So maybe like 1/2, pretty much something smaller than 1. In that event, this is where our graph did not get steeper. It got less steep. Another one that we hear is widen. That happens a little bit more with more advanced functions that we'll study. We'll see actually a little bit later on this year, that vertical stretch and widen more so. But you could say that the line in this scenario, when it's a fraction like that, got less steep. Okay. It kind of leveled out more. All right. So those are pretty much our definitions. Again, the top one, this is where our B value was impacted. And then this guy was more emphasizing our slope. All right. Go ahead. Feel free to pause the video if you have any questions on our definitions, though. All right. Now looking at example 1, it says a gym charges a one-time new member fee of $50 and then a monthly membership fee of $25. The total cost, C, of being a member of the gym is given by this function. Here is our function. And again, this is that starting fee that they were mentioning. And then every single month, there it is, $25. And this is where T is that time in months. Now, for the situation below, we're asked to describe how a graph would change using that given graph, that function as the reference. And for question A, is asking, well, what would happen if they decrease that one-time fee for new members? So by decrease, you could have a couple different things happen. Maybe, for example, let's say they just got rid of it altogether. And sometimes gyms do promote these kind of special, times of the year. Hey, come join our gym. Maybe it's the winter time. Things are a little bit slower. They want more people in. So they might have, these special offers. So they might decrease that one-time membership fee. So let's say they got rid of it altogether. Well, our function then, C of T, is they're still charging $25 every single month, right? But instead of $50 as that starting value, maybe it's now $0. Okay. And if we go ahead and graph this, what we should expect to see is that y-intercept 0. And then that slope is still rising and running at the same rate, though. They're still charging $25 every single month. And so what we would expect to see is this kind of parallel line, but starting off at a lower y-intercept. Okay, so to answer question A, it's pretty much a parallel line that is going to be below the line, the function that they give us. So maybe a different one, maybe instead of $0, they might say, hey, at $35, let's say. Maybe they just change it to $35. But the slope every single time is going to be exactly the same, $25 every month. Okay. So what you would expect to see is that our line gets vertically shifted down. All right. So either like that blue or the purple one. So to answer our question, our graph would just vertically shift downward. So we still have the same graph, it's just it got bumped down. All right. Go ahead, feel free to pause the video if you have any questions on example 1A. All right, now what happens if they say, you know what? No, we're not going to do that. We're going to keep that $50 fee. That, you're joining the gym and you're getting charged that $50. So you're paying that $50 still. But in this scenario, they're increasing their monthly membership fee. Okay, so instead of $25, maybe they're going to charge you, oh, I don't know, like $50, let's just say. So $50 every single month plus the initial $50. And what that graph would look like is you're still starting off at that same y-intercept, right? But instead of up 25, you would have to go up $50 for every 1 month. Up 50 for another month, up 50 for another month. And so we start to see a line that does something like that. We should expect to see it become more steep, right? Because our M value changed, it got larger there. And so our graph became steeper or more steep because our M increased. Our absolute value of M increased. Okay. Now for C, suppose that the gym increases its one-time membership fee and decreases its monthly membership fee. So how would then that change the graph? So again, it is increasing its one-time member fee, the new member fee, but then it decreases its monthly membership fee. So just to kind of give us an example of one, this is our original function. Our new one might be, if instead of $100, they're going to charge, instead of $50 to start and join the gym, they're going to charge you $100, let's say. But instead of $25 every single month, they are decreasing that monthly fee to, we'll go with like $10 every month. So what would that graph kind of look like? Like what would happen to the function here? Well, according to our graph, we'll go ahead and clean up this other one. In this scenario, what we've done is we have increased the B value. So now it's at 100. But our slope is now smaller, right? It's not 25, now it's 10. So in terms of like a nice clean point, you could say that it looks like it goes up $50 at 5 months. So there's another clean point that you could graph, right? Because if you were at this gym for 5 months, then that would be $50 plus $100. You end up with that $150 amount. So that's another clean point. What happens here is we kind of, we increased our y-intercept. We know that instead of 50, it's 100, but notice how it got a little bit more level. You're not paying as much every single month. Yeah, up front, you're paying a little bit more, but every single month, you're not paying as much. Okay. And this is actually pretty handy information because depending on your situation, you might decide, hey, I want to choose this specific contract because I'm either only going to be here for a short time, or maybe I'm planning on investing in something long term, and so you really want to kind of have it where you can save the most money, and so you might then opt for the blue line instead. So you might pay a little bit more upfront, but if you're thinking long term, I'm planning on settling here or whatever the case is, it might be in your better interest actually to pay a little bit more upfront, but then every month pay a little bit less than you normally would. Okay. So it obviously depends on the situation. And this really starts to get into our next unit, systems of equations and inequalities. But we're not going to dive into that just yet. So how would this alter the graph? Well, our vertical shift happened. So we vertically shifted. up, but our graph became less steep. And so that would pretty much be the description for our graph. All right. So guys, now go ahead, pause the video. If you have any questions, obviously feel free to ask, but go ahead and try the your turn D. So once in a year, if they offer this one-time fee is waived for all new members, you know, what happens to that graph? So for question D, your function that you should have ended up with is C of T is equal to $25 every single month. If you have that, that's fine. That works perfectly. If you added the plus $0 for the fee that was waived, that initial fee, that would also work too, because your B value there is 0. So that should be your answer for question D. Now, what you would expect on the graph, we actually did graph this one. Essentially, it would be, it would be our value, our initial value, begins at $0. And we are charged $25 every month. And so to describe like the transformation there, our graph vertically shifted down $25, or I'm sorry, $50. Okay, so imagine taking that original graph and just shifting it down 50. Now, in terms of like the transformations, there are 3 main linear transformations that we talk about. That first one is that vertical shift. Okay. And in question D, that was actually a very prime example of where we saw that vertical shift happen. So, you know, if this was our original graph and they waived the fee, well, your function would look something like this. Notice how the original line shifted down $50, right? So depending on your shift, your B value, the B value controls the vertical shift. And we saw in the previous definitions, you know, B increased, you know, the shift went up. If B decreased, then it went down. Okay. But one of the 3 main ones is that vertical shift, and B is what controls that. The next guy for linear transformations is your M value, which is controlling the steepness. So steepness. Okay. This is also pretty much in terms of like widening or stretching. So you'll hear teachers mention that, stretch / widen, especially when we get to our quadratics unit. We'll be emphasizing more of those. You could say it got steeper. That's kind of the stretch version of it. Or it got less steep or more level. And really the value that controls that is your M. So M value controls that. Okay. And then the final main transformation that we see with linear is what happens when you have a negative. So this is what we call a reflection. Okay, and this is when we have a negative value for our line, or really our M value. Okay, and what happens, the technical term, the mathematical, is it reflects our line about the x-axis. So that's the reflection happening. So that's where M is pretty much some negative number. The negative is what's causing that reflection to occur. All right. So those are really the three main transformations. The vertical shift, B controls that. The steepness, M is what controls that steepness, whether it gets steeper going up. Maybe your value is really high, like 5 or 7. Whereas if it gets less steep, maybe it's a fraction like 2/3 or a half. And then the reflection is, it is reflected about the Y, or I'm sorry, it is reflected about the x-axis if your M value happens to be negative. Okay. Go ahead, feel free to pause the video if you have any questions at all on any of those definitions.